Welcome to BSides Munich 2020 in our talk for the art of bypassing endpoint protection. In this talk, we're going to be basically talking about a lot of stuff about evading, the antivirus evasion techniques, PowerShell, let's say the different evasion techniques or different OS with our beloved one Windows, of course. So a bit of disclaimer before really starting. We're going to be showing you different techniques, and that involves a bit of vendors. So our purpose, right, is only for research, without any offense or violation to these vendors. Just part of from our research. So who we are? My name is Jamil Napo, and I'm principal offensive security consultant in Capgemini. Basically, I have around a decade with the breaking things legally, and yeah, I have also my colleague Islam right here. Gonna be doing deal in this talk. So, giving you the floor.
Hi everyone, my name is Islam Reda and I'm an offensive security consultant at Capgemini. I will be talking today with Jamil. We will try to give you an insight on how to evade antivirus and how to make your red teaming engagement more effective.
Cool. So, moving forward, the agenda of this, the upcoming 30-40 minute, gonna be talking basically about, the issues of red team and engagement, why you need it. We're not gonna be telling you roughly what is red teaming. This is more advanced tool. We're gonna be, also displaying a bit of Evasion techniques, tools, things about the manual development, stuff about, Windows API, PowerShell and shellcode, and the cool things in .NET Core and .NET in general. Alright, so in order for us, to start, if you're doing, let's say, a red team engagement, and let's say you're facing, you're doing return movement, you're trying to, break into the domain control or whatever. So it's obvious sometimes that you're gonna be, facing EDR solutions. And it's not, sort of, let's say, OSCP lab or something that gonna be real world. So that means you're gonna be facing firewalls, gonna be facing, AVs, advanced AVs, perhaps that involves more than the, let's say, semantic analysis or signature-based detection. So it could be behavior analysis sometimes. That depends really on what you're doing. So let's demonstrate it this way. So when you start, let's say you've got into an endpoint. So the lady right here, you compromised it, with the SMB hash, BSexec or whatever. Now, on the other hand, you would need to gain access to another endpoint in the system that in a direct connection with the domain controller. But right here, you got a bit of wall. You got an ADR on this endpoint. So how you're gonna be bypassing this, and what kind of tools that you're gonna be using? Mainly, how you're gonna be bypassing this. This sometimes it may look like simple, but sometimes it could really break your red team and engagement. So that's why you would really need to be prepared. Now, I'm gonna be talking about the evasion tools that a few companies, and I work for small companies, and not all of them really afford to pay Cobalt Strike and cryptos or whatever, because at the end it is not legal. But on the other hand, if you're gonna be doing evasion, if you're gonna be creating new FUDs for detectable payload or whatever, you're gonna be using encoders. So encoders is sort of, it's not cryptos is mainly transfer. Let's say you have an executable, then you get you transfer that into perhaps base 64, and then you in the runtime you switch it back or whatever. Now this kind of techniques could work perhaps before 5 years, but in the 2020 I'm not sure if it's still encoders work. We're gonna see this in action. You got packers. You could be used, sort of packer like QPX, that the most popular one, but also get detected because of its resources and stuff. So yeah, signature-based tools like YARO tools, YARO rules can detect this very easily. You're gonna be using also binders or cryptors. Now cryptors, if you develop on your own, that means in business you don't have really time. So it's really obvious. You're gonna be buying tools and stuff, and on the other hand, it's illegal. So what you're gonna be doing, you're gonna be perhaps taking the open source one, and here you come into the problem. Right here, you've got Cobalt Strike, you've got VO. It's well known in the community for crypting, creating payload. I'm telling you, if you're gonna be using it, it's all detected. It's all detected. Metasploit, whatever, Post C2, all of these open sources are detected. The reason being, the AV companies is paying full-time guys in order to research and GitHub and create rules against these guys and place signatures and stuff. So I'm telling you, it's not the right choice. All payloads, of course, get detected, even if you create a new IOCs. The IOCs again is really popular. Now, right here, I'm gonna be jumping into when you run a malware, what could be the ways in order to bypass the ADs. It could be using you're going to be using let's say Mutexes or persistence. I'm going to be talking this in the upcoming slide. But just as for now, think about it. You want to run something and then keep it over there and make sure that it's if there's another instance that are running the target system, so you're not getting multiple reverse shell back. Gonna be running in the memory now. The modern AVs are able to detect in the memory unless you encrypt it and stuff, so that you make it difficult for them. Or it could be run executables, and when you run executables, you're gonna be facing the UAC. I'm talking about Windows user access control. There are stuff to bypass it, but sometimes you fail on bypassing these, and then you run in a normal user mode, and the user mode could be let's say not allowing you to do any kind of persistence and stuff. So you need to overcome this. I'm gonna be talking about certain techniques. And process hallowing, if you don't know what's process hallowing, just in simple terms, it is simply injecting sort of payload into a process in order to evade the detection. That could be if you have a process, you simply just inject in that process and continue. But that sometimes fail, and sometimes the behavior analysis tool detect that. DLL injections is really simple. You just put your DLL if you find codes or something or whatever in the target application. But this requires you to know beforehand what kind of applications or stuff that are running on the target host. I'm not going to be diving into delivery techniques. Now, for the Mutexes, what are the Mutexes? What does it stand for? What normally, if you, regardless, the program language that you develop in it, it could be Java, it could be C# or whatever. But anyway, if you're going to be, first running your own stuff and care about the persistence, so in this case, you would need, to generate your own Mutexes. Now, the Mutexes means like random value, random string. Think about it. When you generate it, you're going to be basically calling. If you're working in Windows, you're going to be calling in Windows API, when API create Mutexes. This basically this function can handle, regardless of the language that you create your malware in, the Mutexes creation. Now, in this case, you could also check if there are other running instances. That the way you do it using the Mutexes. It's not about the process name. But some EDR solutions could detect you when you're going to be getting the MD5 out of that Mutexes, and basically eliminate your privileges. But this is what the Mutexes stand for. Normally, I've seen red team engagement. Not a lot of people really care about persistence or whatever. That's more about remote access trojans or tools that use real-world attacks. Now, the fun with the Mutexes is that you can run a file and, on the other hand, take a Mutexes value of another application. So that means, let's say you run your application a portable way, you try to write in the registry or some places that your application gonna take a bit of priority and run once, whatever what kind of things that you can access it. That means if they use UACs enable, so it's kind of difficult. But anyway, it's basically you can also spawn another Mutexes. So you basically take another application value, the Mutexes value, and then when the system asks for it, your application runs. So that's different than the DLL hijacking or something. It's, let's say, I call it Mutexes hijacking. You can find it, more information about it in Microsoft website, the cool website. All right. So in terms of persistence, Now, the obvious one, you can see it right here. It's the run ones and registry keys. You try first to check. These are the a bit of advancement, or the first check if they can write to the registry, and then on the other hand, if there's exception thrown or whatever, they just forget about it, or sometimes they try to write in order for them to keep the persistence of the malware. You would sometimes really care about this in red team and engagement, not let's say like the rat, but on the other hand you would need to care. What if the machine crashes? What if your payload doesn't work? There could be a lot of things involved, and especially if you work in a production environment, so you need to really be careful about running your stuff. If you're going to be working on the registry, you could be working with the servers or whatever. Anyway, so you got user init key, explore startup. You could run on ring 3 mode or whatever that you can inject basically in the registry keys. The MBR record, the COM object hijacking, or perhaps in the system 32 you can place it for the file that get initiated or called like the app any DLLs. So right now I think my colleague he gonna start with a bit of PowerShelling. So take the floor again, mate.
Alright, so we now are going to talk about PowerShelling. What we usually do is using these commands: download file, download string, but we have been using this for a long time and it's already getting detected by antivirus. So we try to obfuscate our payload. We try to hide this from the detection of the antivirus using obfuscation, but it's also getting detected. So what's even better than doing obfuscation is not using at all download file or download string. Here is an example of a script without using download file or download script. We are using TCP socket. We start by defining the client, the stream and buffer, and define our variables. The client stores the IP and the port for the TCP socket. The stream gets the stream from the data that we already entered, and we store our buffer in the buffer variable, and we encode it using ASCII encoding. Here we write to the buffer and we invoke PowerShell, and we start reading from the buffer and saving it in the variable bytes, and then here we start decoding the buffer and storing the data in the data variable using the get string, and then we go on in this if statement by invoking the command data and outputting in the terminal. So it's a try catch block, and here's just some exceptions. So we go on now to the PowerShell demo. We verify that Kaspersky is running, and we can see it's running and everything is working. We start by scanning the script that we created, and it's not detected. And now we have our command ready to run the script. We run the listener and run it, and here we go. We get a shell back. And who am I to verify it? And it's working. And let's take a look so we know we are not cheating. Okay, now we need to verify that after we got the shell, it's already not detected. And we are going to scan it using 36 different antivirus products. So we upload it to clean scan, and let's see. As we can see, none of the antivirus products till now detected our PowerShell script. Let's wait for Sophos and McAfee, and it's still undetected. So as we can see, with a simple technique, we have bypassed the detection of almost every antivirus, and we got 0 detection rate from 36 antivirus products. Okay, so for you who prefer to work with MeterBreeder, to use it as a payload, we are going to use another technique. We are going to use a MeterBreeder payload and include it in a C container. We are going to use MSF Venom to generate our payload and encode it using shellcodes, and then take this shell and include it in our C container and execute it in a clean executable. So how is it done? In the beginning, we will start by creating an executable without our technique and see how will the antivirus deal with that. So we are creating MSF Venom, Windows MeterBreeder reverse TCP, and our local host and our local port using the shellcodes encoder. Here we are just creating an executable with an encoded payload, which is the old way to create the payload. And now let's copy it to our victim. Okay, as soon as we copy it, it's detected by the antivirus. And let's verify by scanning it. And it's gone. So the normal encoding technique, it's not working anymore. So what we are going to do is we are going to create another payload in C. We're just changing the extension here. After we generate the payload, note the size. Here it's 557, and let's copy our shellcode. We will use that. Let's create a C++ project. We'll name it clean. Let's create our main file. We will start by including the necessary libraries, and that is studio.h. That's for standard input and output. And we will include Windows, which is the declaration for Windows APIs. And then we define a constant with a payload array. And then here we add the size that we already noted during creation of the payload. And now we create our main function. Okay, here is our technique. We will create an inject. It's empty for now, and we will create a statement here just to verify when the payload is working. Here we start by virtual allocation, so that we can allocate to inject in memory. So we do mem commit, page execute, read write. Mem copy, and here we copy from the payload into the inject with the size that we declared. And here we get our payload. And do return to close gracefully. Okay, we are done. What we can do now is just adding some dummy files. You can create a resource bitmap and create another item here, call it GUI, and just fill in any comment, just confuse the Yara rules. So getting network information and release and build. Now we have our clean executable. We can copy it, and let's see how the antivirus will deal with that. First, let's set up a listener. We are using Metasploit because we used a meter-bretter payload. So exploit multi-handler. We set our payload. So Windows meter-bretter reverse TCP. We set our local host. And our local port, and start listening. Okay, we go back, paste it, scan it, and it's not detected. So let's try and run it. And here we go, we get a meter-bretter shell, and we are in. Let's verify it. Who am I? And we are in. Okay, now it's time to we have seen some techniques. It's time to talk what is the use of this in a real world scenario.
Well, thanks Islam. Well, I think the meter-bretter is definitely not used in the real world scenario, isn't it? Now, you know, guys, you've got red team and you got the rats. When you're going to be doing red team, you're not going to be really running around, and it becomes really different. But on the other hand, there are some similarities. Now, in this table, if you're doing red team in engagement, you don't really care about resistance. You just care about, you know, getting into that lady machine, and, you know, from that popping that thing and then going into the domain controller, perhaps. So it is basically like playing around. Now, in real world, resistance is really crucial, and we touching upon some certain points right here, and also the red teaming is all over when you are, you know, you take the domain admin, and in the real world it's never or, you know, over. You're gonna be updating bootnet and stuff. So the attackers, really, the criminals, they really care about maintaining their access, and also, you know, if you got, let's say, you're gonna be leaving traces, perhaps sometimes for the blue team, sometimes this could be part of the deal, and, you know, in the real world they get really avoid detecting. I'm talking about, you know, could be research institutions and stuff doing these kind of crimes, especially if they are motivated in political way. So they've got money in terms of investment. Now, in the red teaming, you are not really doing a data breach, don't you? So it's mainly about simulating an attack. For the real world, what are you going to be doing? You're going to be talking to the guys, all right, give me my data back. So it's not really it's not really the case. So if there's a breach, then welcome to the club. But right here, I'm going to be also talking about a bit about Yara rules. So Yara is been used for by a lot of vendors without naming them, but let us say the 90% of the majority of the signature-based detection are really used in Yara. So they kind of embedded Yara into their engines and developing interfaces and stuff. But at the end, you've got the same for signature-based detection. So you basically let's say you've got certain string. It's the same in Linux when you say string about certain file. It could be ASCII, it could be bytes, it could be hex. So you basically say about the meta description about that file, the resources, you write a bit of conditions, signature based. Now on the other hand, bypassing the signature base is not really difficult. It is not really difficult at all. But it just needs a bit of time about looking what's in there. So besides Yara rules, you've got the behavior analysis, malware detection. Now it's still in the learning curve. Because you've also get a lot of false positives. And I've done some engagement, myself from my experience on endpoints on network that contain, 20,000 endpoint, 2,000 endpoint. What I'm telling it's a false positive, so it's a time consuming on the other hand. But without digging into that much detail, the behavior analysis, it could be using machine learning, a data set, training set, feeding it with the data, published IOC, TI part. Sometimes they involve process names, and also an attempts perhaps to gain access to certain certain IPs, blacklisted IP, whitelisted IPs, dynamic code analysis, static code analysis sometimes. Or perhaps if you let's say you're trying to create a process that gonna be, let's say you make it an API call, Windows API call, or Linux or whatever you may use in order to bypass the sandbox. So if there's a call for certain process that gonna bypass the sandbox environment, so that way it could be classified and the behavior analysis as the as a malicious, gonna flag it as a malicious file. You can also when you spawn PowerShell. Download string, these kind of data. So that also the way that you may get detected. But of course there are different techniques to overcome this. Because at the end it's a machine, it doesn't have the human intelligence. But with that being said, I'm gonna be jumping into ngRat. So ngRat, this guy, has been used over the past, let's say 6-7 years, for by governments, by intelligence, by nations attacks, and basically started in the Middle East, and then it's spread over the world. So here what I'm calling ngRat vs the world. So it's quite true. And the reason that we choose ngRat in order to run our POC is because this lady is ngRat is I think famous. As a detectable IOC, more than Pamela Anderson. So that's the reason that we use it in order to show how, in a simple techniques, that you can basically clean it from all EDR solutions. So right here, before 6 years or 7 years, there wasn't something called .NET Core. Now, when .NET Core came to the table, it's basically putting the capabilities that Java has on the table in terms of across the platform, and that brings available for the criminals, because the more they can reach systems in an easy way that could take you a couple of lines in order to modify your payload, shellcode, byte, whatever you may working with. In this case, you can embed it in .NET Core. Now the cool thing about .NET Core, you don't really need dependencies. You can include all the dependencies in perhaps one file, then run it in Linux, Windows, Mac, or whatever, based on Mono. So in this case, that's really cool. But there's a disadvantages when the malware developers, FUD there, make the executable fully detectable is basically the size, because when you include a lot of stuff, so that way they're gonna be a lot of things. But right here we make it really simple, plain simple. Gonna be starting with the demo. For NG-RAT, we're gonna see it both ways. So let's get dirty. All right, so this is the lady. I'm starting it. Listening to normal port. It's installed. This is basically the server. So I'm building into my local host, binding that same port, and adding BSides Munich as the victim name, without including any process protection or whatever. We can do that ourselves, but just care about creating the client. So I have already a client, and then replacing it with the new created file right here, and then we got it. Now what we're going to be doing is taking this file. Let's check it out first. Scanning it without any kind of specification or encryption or whatever. So we're using right here 31 scanning, ADR, AV right here, and probably gonna come across all of them perhaps. So right here you can see it's still uploading, and you got 22 out of 31. Surprisingly, Kaspersky saying undetected, but we're gonna move with that anyway. So yeah, we've got other ladies who are saying it's a clean. No offense, but right here you can see it's all got detected. Roughly we have 26 out of 31. So basically all of them, and there are still ladies doing pending and scanning. So that for obvious reason we just took the executable, and then we just uploaded it out of generating it from ng-RAT builder. Now let's check the file size. It's 31 kilobyte, 32 on the disk, and the next step that we're going to be creating already this C# project console application. Right here, we have, this is the program CS, the starting place for our application. We have basically the main method, and we have a class definition called util. And util we use encrypt me and decrypt me. We're using right here, a bit of threat. If we jump into utils right now, you can see that what I'm doing is basically encrypting the string that I'm getting and the byte. Taking these bytes, creating a key. You can define the key that you want. The initialization vector, the EV, and we're using right here the Rundle algorithm, which is really basic, normal cipher CBC mode without padding, for encrypting and returning this as a byte array. And the decryption is done the same basically, but the one thing that is different, we just transform it. So basically we're encrypting with the key, and then we're decrypting with the key. And right here we're just calling the output, the file that we generated from ng-RAT already. We outputting it into sr.txt. It doesn't matter the extension right here. A bit of thread, and then we're using system.reflection.assembly.log. I think I can write a book about this too, but we're gonna be moving forward. So it's basically just loading the application, and the changing its entry point while the main application already starts. So all right, right here you can see that the folder is empty, and we right now what we're going to be doing is basically just copying this into our main workstation directory, for obvious reason, because I don't want to define the path, so it's easier right here. So reading from the client, which is the server that we generated using ng-RAT, output into sr.txt. You can't commit this line or whatever. I'm gonna be running in this demo. I'm just putting a thread just to make sure that everything works. Alright, here I'm doing right now a build, so please build a project for me so that the output gonna be nice.exe, as you can see right here in the output. Now if we go into the project directory, we're gonna find in the bin directory and debug that our file. But you see, the txt is not created that for obvious reasons, because we need the compile time right here. So we're gonna be now starting the application. It's gonna read the bytes from the generated Trojan, encrypt it, decrypt it, load it into the main application that got started. So sort of like, you know, doing jump. So start the application, encrypt, decrypt, and load the other application into the entry point that we loaded. So it's like really simple techniques. Now it's gonna be a bit slow. You can see right here, you know, run as administrator, even though without UAC, I'm getting the notification, which means this machine got compromised, and we've got the reverse Trojan back. You can see that right here, it's working. It's a bit, I think, slow at the moment because I'm using debugging right now, but you can see the files. Let's see if we're gonna get the processes. Gonna jump into the connections. All right, so we are getting the connections right here. You can see it's working, even though it's in scan time or runtime. All in all, it's encrypted. Now closing this error is basically because I'm running it in debugging mode. But let's now, we verified it is working. What we're going to be doing at the moment is basically see what kind of endpoints EDR Solutions AV can detect our nice file. So right here, you know, you can see the old one. Let's see the new lady. So browsing it. Right, so let's see. Users Joe source repo console application 1 bin file debug. Yeah, that's it. Scanning. Let's see what we're gonna come up with. Alright. So alright, so here we have 31, same as the old one. We got in total 40.5 kilobytes, which is not even close to 1 megabyte, and it's clean from all AVs. 0 and 31. You can see right here, it's really hard for the signature based and also the you know, the behavior analysis tools to detect the encryption, because obviously they don't have the key. Now someone may say that it's really easier because you can decompile the .NET code really easily, but I'm telling you that there are methods that you can basically disallow your code to be decompiled. So with that being said, simple techniques, creating, just to wrap up, creating, you know, taking our output from NG-ROUT, the most famous route, so it's detected from everything, and then, you know, we get in its byte, we encrypting it using symmetric encryption, run the algorithm, creating, you know, AV, we creating the initialization vector, and the key, we're using the same key to decrypt, and it's all hard coded, even though it's clean. So the conclusions: if an AV detects a signature, that sadly means millions or thousands of people got hacked or compromised. Because the way that the signature-based detection works is basically when people, you know, get hacked. Let's say 100,000, some one of them smart guy uploaded it to Powershell tool, you know, analysts get it, and then, you know, they start, you know, deploying the update for it. So installing AVs is crucial, of course. But just the fact that if someone got detected, that means millions got hacked. Bypass and signature-based detection, as you've been seeing right here. So we used the PowerShell. We used, you know, we didn't even any kind of investigation on the PowerShell itself. We haven't done anything with that. Just creating it, using socket, and got bypassed. The other thing that you've been seeing, the Meta Project shell, which is also, you know, detected by a lot of people, and also, you know, bypass with a simple technique, just creating C file, get that shellcode. And sometimes, you know, maybe other AVs can detect that, but on the other hand, you can just split the shellcode to base 64, then you decode it, and then you can concatenate the string. So you make it really harder for them. So it's not something really difficult. And when it comes, we speak roughly on this in red teaming, and it's really crucial that you know what you're doing. Because sometimes I've seen some consultants in different engagements, previous companies that they're using just downloading rats and downloading shells and stuff, executing without understanding so they what they're doing. So at the end, what they are ended up with is basically a malware, sub malware running, and instead of securing your client environment, you basically you understand what I'm going to be saying. So if you guys gonna be following us, so you've got Islam right here, my Twitter, and also if you're curious about the materials, the scripts, all the PowerShell shellcodes and stuff that we written during this talk, you can find on bufferoverflow.net/this long letter. You can just write buffer overflow and gonna get there. Just to not forget the references. So these are the guys who are using stuff content from there. And developed our own content. So thank you so much.